Right, so this video is going to take us through ionic bonding. We're going to consider the basics, so which type of atoms bond and why. We're going to have a look at what happens in ionic bonding using the example of sodium chloride. We're then going to have a look at another example where it's slightly different, looking at magnesium oxide. And then we're going to look at how you actually work out formulae of an ionic compound. So the basics. Which type of elements ionically bond? It's metals and non-metals. So metals and non-metal atoms. These are the ones that will ionically bond. They do it by the transfer of electrons. So metal atoms will lose electrons and non-metal atoms will gain electrons, always with the aim of getting a full outer shell, very much like group 0 elements, the noble gases. So what happens? We're going to have a look at the example of sodium chloride. Sodium is in group 1. It has one electron in its outer shell. And it's these electrons that are in the outer shell that we are most concerned with regards to ionic bonding. So it has 11 electrons, 2 in the first shell, 8 in the next shell, and 1 in the final shell. So that's sodium. Chlorine, so a chlorine atom, is in group 7. It's got 17 electrons. So it has 2 in the first shell, it has 8 in the second shell, and then that's 10 in total, so it has 7 in its final shell. So that's 17 electrons. Now, in order to fill sodium's outer shell, it would need to gain 7. Alternatively, it could lose 1. Losing 1 is much easier than gaining 7, so that's exactly what happens. Sodium will lose its 1 electron to chlorine. So chlorine will gain this electron. In doing that, they will become charged. That means they're now ions, so they're no longer atoms. Now an ion has a charge. You can find the charges on the reverse of the periodic table on the data sheet. Because sodium has lost a negative charge, it actually becomes positively charged. That's because it now has more protons than it does electrons. Chlorine now has 18 electrons and it still has the same number of protons as it did have, so it has 17 protons. Now it has gained the electron that was here from sodium, so this electron here was sodium's. So chlorine is now an ion. We put square brackets around it and it becomes negatively charged. So we've got Na plus and Cl minus. These are attracted to each other because they've got opposite charges. Second example I'm going to look at is magnesium oxide. Now on this one I'm only going to draw the outer shell electrons because those are the ones that are involved in bonding. So magnesium has 12 electrons and it's in group 2. So straight away, because it's in group 2, it only has 2 electrons in its outer shell. So I'm only drawing the outer shell electrons. So that's magnesium. Oxygen is in group 6. So that means it's got 6 electrons in its outer shell. Again, I'm only drawing the outer shell electrons. Now, with regards to this one, obviously magnesium will lose its outer 2 electrons to oxygen. That then means magnesium has a full outer shell. It has the 2 in its first shell and it has the 8 in its second shell. So now I'm drawing the electrons that are present. Square brackets. It's lost 2 electrons. It becomes a 2 plus charge. If you're not sure about how the ions get their charge, have a look on your common ion chart Okay, all of the charges are on there. Oxygen has got 2 electrons in the first shell and it has 8 electrons in the next shell. So the same electron arrangement as magnesium has. The difference here is because it has a different number of protons, it's a 2- charge. Okay, so it's got 10 electrons and it's got 8 protons. It's got 2 extra electrons, 2 plus, 2 minus. Right, in working out formulae, you need to be aware that overall an ionic compound is neutral. It has no charge. So the number of positive charges need to balance out the number of negative charges. So if we're looking at magnesium chloride, you've got Mg 2 plus and a Cl minus. So here we have a 2 plus charge, but we only have a 1 minus charge, and we need two minus charges. The only way you can do that is by having 2 chloride ions. So the formula would then be MgCl2. If we think of another example, so aluminium chloride, Al3 plus, Cl minus. Again, we've got 3 plus charge and we've only got 1 minus, so we need another 2 minuses, AlCl3. There are other ways of thinking about doing this. Mg2 plus, Cl minus, the 2 goes here, and this is a 1, so it's a 1 minus. So you have Mg, there's only one of them, and then Cl2 has gone over here, so Cl2. Al 3 plus, Cl minus, this is a 1 minus, so you've got Al, 1 goes next to the Al, and the 3 here goes next to the Cl, Cl3. So those are the key basics with ionic bonding.